How do disparate tissues from multiple pharyngeal arches and distant somites coordinate to form the highly specialized human tongue? Morphogenesis begins at approximately 4 weeks of gestation, deep within the floor of the primordial pharynx. The first structural sign of development is a single median triangular elevation, the tuberculum impar. This swelling emerges from the mesenchyme within the first pharyngeal arch. Immediately, 2 oval lateral lingual swellings develop on either side of the tuberculum impar. These 3 swellings establish the first arch's contribution, while the remaining arches have yet to participate in the developmental process. Inside those lateral lingual swellings, mesenchymal cells multiply rapidly, driving an expansion of tissue mass toward the midline. As they expand, the lateral swellings merge, overgrowing the tuberculum impar to form the entire anterior 2/3 of the tongue. Externally, this fusion leaves the midline groove. Internally, this boundary forms the fibrous lingual septum, a dividing wall beneath the surface. Because the lateral swellings completely bury the median structure, the tuberculum impar contributes no recognizable structure to the adult tongue surface. The tongue's anterior 2/3 is an exclusive mucosal derivative of the first pharyngeal arch, possessing a distinct identity before posterior sections form. How do disparate tissues from multiple pharyngeal arches and distant somites coordinate to form the highly specialized human tongue? Morphogenesis begins at approximately 4 weeks of gestation, deep within the floor of the primordial pharynx. The first structural sign of development is a single median triangular elevation, the tuberculum impar. This swelling emerges from the mesenchyme within the first pharyngeal arch. Almost immediately, 2 oval lateral lingual swellings develop on either side of the tuberculum impar. These 3 swellings establish the first arch's contribution, while the remaining arches have yet to participate in the developmental process. Inside those lateral lingual swellings, mesenchymal cells multiply rapidly, driving an expansion of tissue mass toward the midline. As they expand, the lateral swellings merge and overgrow the tuberculum impar, forming the entire anterior 2/3 of the definitive tongue. The external remnant of this fusion is the visible midline groove, while internally, it leaves behind the fibrous lingual septum. Because the lateral swellings completely bury the median structure, the tuberculum impar contributes no recognizable structure to the adult tongue surface. The anterior 2/3 of the tongue is an exclusive mucosal derivative of the first pharyngeal arch, possessing a distinct structural identity before posterior sections form. Shifting our focus caudally, we look behind the newly formed anterior body to the remaining elevations in the pharynx floor. Behind the oral tongue, 2 structures appear, the copula and the larger hypopharyngeal eminence. The copula forms from the ventromedial parts of the second pharyngeal arch. The hypopharyngeal eminence develops from the mesenchyme of the 3rd and 4th pharyngeal arches. During development, the mesoderm of the 3rd arch undergoes a period of rapid forward and upward growth. This 3rd arch tissue overtakes and buries the 2nd arch copula until it reaches the posterior edge of the oral tongue. Consequently, the 2nd arch provides no mucosa. The posterior 3rd forms from the 3rd arch, and the extreme root from the 4th. The boundary where the 1st arch tissue meets the 3rd arch tissue is marked by a V-shaped groove, the terminal sulcus. At the precise apex of this groove lies a small pit called the foramen cecum. This site is the embryological point of origin for the thyroid gland. From this point at the base of the tongue, the thyroid primordium descends through the neck via the thyroglossal duct to its final position in front of the trachea. The tongue's surface anatomy serves as a permanent anchor point, marking the initial site of the body's primary metabolic gland. If the pharyngeal arches provide the external mucosa and connective scaffolding, we must look elsewhere for the source of the tongue's internal musculature. The myoblasts that form the tongue's muscles originate within the occipital somites, located in the posterior neck region. These myoblasts migrate from the occipital region into the floor of the pharynx to populate the interior of the tongue. As they travel, these myoblasts drag the hypoglossal nerve, cranial nerve 12, along their migratory path. Between weeks 8 and 11, the surface mucosa specializes. The valate and foliate papillae appear first, followed by the fungiform and filiform papillae. Between weeks 11 and 13, invading gustatory nerve cells interact with the epithelial cells to induce the development of functional taste buds. The human tongue is a dual origin system. The pharyngeal arches build the external sensory structure, while the migrating somites provide the motor engine. Structural anomalies in the tongue are the physical results of disruptions during this embryological timeline. Normally, cell degeneration frees the tongue from the floor of the mouth. If this fails, the thick restrictive frenulum is known as ankylglossia, or tongue tie. If the two lateral lingual swellings fail to merge in the midline, it results in glossoschisis, a bifid tongue with a deep central cleft. Microglossia, or an abnormally small tongue, is typically associated with the underdevelopment of other first arch structures, such as the mandible. These anatomical variations represent failures at specific cell migration or fusion checkpoints during development. The adult tongue's cranial nerve supply is mapped through these specific embryological origins. General sensation for the anterior 2/3 is provided by the trigeminal nerve, cranial nerve 5, as this tissue derives from the first pharyngeal arch. Special sensation for the anterior 2/3 is handled by the chorda tympani branch of the facial nerve, cranial nerve 7. General and special sensation for the posterior third are supplied by the glossopharyngeal nerve, cranial nerve 9, the nerve of the third pharyngeal arch. Cranial nerve X, the vagus nerve, supplies the extreme posterior root and epiglottis, corresponding to the fourth arch's contribution. All motor innervation, excluding the paladoglossus, is supplied by the hypoglossal nerve, representing the migrated occipital somites. The neuroanatomy of the human tongue is a permanent record of the earliest developmental history of the embryo.